thank you for participating on today's webinar. With several participants still signing in, we're going to kick off today's broadcast at 2 minutes after the hour. Thanks again for hanging in there with us, and we'll be back to you shortly. Good morning and good afternoon. Thank you for joining us on today's broadcast entitled Real-Time Recommendations with Redis. It's with great pleasure to introduce today's presenter, Ninad Devadkar, Principal Engineer at Intuit. During today's broadcast, Ninad will demonstrate how to use Java, Spring, and Redis, spring-websockets, and spring-data-redis to power a real-time recommendation system. Throughout the broadcast, Ninad will be taking questions from our participants. If you have a question, please use the question and answer panel, and your questions will be answered in the order that they are received. This broadcast is being recorded for playback purposes and for you to share with your colleagues. At this time, I'll turn the broadcast over to Ninad. Ninad, take it away.
Awesome. Thank you for introducing me. Hello, everybody, and thank you for coming and welcome to the presentation. My name is Ninad Devadkar, and I'm going to be talking about real-time recommendations using WebSockets and Redis. A little bit about myself. I work in Intuit in the QuickBooks Self-Employed division. I'm a full-stack developer, and although I've used quite a few different programming languages over the years, I'd say my backend expertise is in Java and .NET, and front-end is in AngularJS. I'm also a Spring contributor. My latest contribution has been to the spring-data-redis project. As you know, Redis introduced geo commands in the latest version, 3.2, and I have added support for those in spring-data-redis. In addition, I'm also active on Stack Overflow, mainly in JavaScript, Java, and Spring topics. So let's dive into the presentation. First, let me tell you a little bit about what QuickBooks Self-Employed is, because that will help us understand the use case better. QuickBooks Self-Employed helps self-employed people like artists or dancers, Uber and Lyft drivers, etc., find tax deduction and be compliant with IRS rules and regulations. According to the recent surveys and data, what we found out is that by the year 2020, about 30 million people in the US will be self-employed. And so we are proud to be helping these people find tax deductions and pay their taxes very easily using our product. And how do we do this? We do this by connecting to the bank account and importing bank transactions. Users can then categorize these transactions as business or personal. Any transaction categorized as a business expense can be a tax deduction, and our product can be used to create something called as a Schedule C, which is an IRS tax form, and which can be shown to the IRS as proof that this was a valid deduction. We also have an interface through which users can pay IRS their estimated taxes directly. Self-employed people have to pay this tax 4 times a year, and so our software makes it much easier for them to pay it. We also integrate with TurboTax for hassle-free filing. And in addition to a web presence, our iOS and Android apps help self-employed people do mileage tracking. And I'll show that to you later. So it's been about 2 years since we launched in the US and about a year since we launched in the UK. Now we are planning to go global in this year and planning to go to about 6 or 7 countries this year using our mobile apps only. So let me demo you our iOS app to show what the product does. Okay, so first, users categorize their transactions as business or personal. They can log their work miles automatically. So whenever you drive for work, you can deduct that as a business expense. We also give an overview of the finances because many users do not have a great way of knowing whether they are making a profit or not. And of course, we also integrate with TurboTax, which is an Intuit product. And so users can easily file their taxes. So this is how our iOS app looks. Now I'm going to demo you 2 workflows in QuickBooks Self-Employed that demonstrate how we use WebSockets and Redis PubSub in tandem. I'm going to switch to a browser. Yeah. I'm signing up for QuickBooks Self-Employed. As you can see, I'm using my local box so that I can also show you the backend code. Okay, we're logged in. Just open this up. Okay, let me log in as a different user. I think some issue with this. Okay.
While Nainad is getting his presentation and demo up, feel free to post any questions that you might have.
Yeah, so now I'm logged in. First things first, we're going to connect the bank account. Okay, and we support over 19,000 institutions, financial institutions all over the world, and more than 10,000 of those are in the US. And that includes, all the usual suspects like Bank of America, Chase, Wells Fargo, etc., and also all the small credit unions that are there in the United States. Okay, I'm going to use a test bank now. So what's going on in the backend is that we are using an Intuit service to go to the bank, connect, and then get transactions, download transactions from your bank. Okay, and this can take anywhere from, like, let's say a minute to 5 minutes, depending upon how slow the connection is between our system and the bank. And this is long polling. This can take a while, so we don't want the user to be hanging in there, nor do we want to do polling all the while at the back end. Okay. You can see now the bank has been connected, and these are, let's say, the two fake bank accounts that we have. Okay. I'm going to click on next, and now we have downloaded transactions. So the user can now go into the transactions tab and then mark them as business or personal. Okay, I'm going to go back to the presentation. Okay, this is the flow that I showed you guys right now. I just want to make a point that this is a very critical process in the user flow. Almost a make or break point where we can wow the user with our technology and make sure that the user understands the value of a product. Okay. Now the other very important feature that I'm going to show you is the recommending rules based on user behavior. After the user has started categorizing transactions, the product learns from the categorization and recommends rules to help the user save time. So if, for example, the user categorizes, let's say, 3 Walmart transactions as business, we understand that he or she is going to categorize the rest as business as well, probably because they go to Walmart for the business needs. Okay. And so the product pops up a recommendation to the user. Now let's go and I'll show you this demo for recommending rules. All right, so I'm gonna just sort them by transaction, and let's say the user is going ahead and categorizing the Chipotle transactions as business. Up pops a rule asking the user to create a new rule. Up pops a modal to show the user to create a new rule. Okay, and the user also wants it to apply to past transactions, whatever you see here. And so after that, all transactions with the name, the description Chipotle will be marked as business for the user. So the user never has to go in and manually, search for these transactions and mark them as business. They can, of course, override any rule as they want, change it if it was a one-time occurrence. And this feature has made our users very happy. When they start using the product, they learn the value right away. They know that we can save them time as well as help them with the tax deductions. And we have over a 60% rate of acceptance with a rule recommendation engine right now, and it's going up all the time. We are using machine learning and trying to figure out the different businesses that users generally go where they want to do business transactions, and helping them create rules right away. Okay. And best of all, we have a unified experience across web and mobile. The web has mobile apps now use WebSockets to get these recommendations. And right now I showed you the web flow further in this presentation, we'll go through the mobile flow as well. And this communication is enabled by the communication between the browser and app servers using WebSockets, and the backend processes using Redis PubSub. I have some questions here. I'm going to just read them out loud. First is, Redis is really known for being extremely fast, but I've heard it suffers from availability. Have you done anything to increase reliability or availability? Or have you not had these issues? So we have not had any issues with availability so far, nor with reliability. We are currently using open source Redis, but we are also planning on using Sentinel for increasing the availability of Redis across data centers as well. And we are also looking into using Redis Labs as well in our product. This question was asked by Justin Simmons. Another one is, do you use a specific rules engine, or is this Quicken specific? Right now this is proprietary. This is QuickBooks Self-Employed specific, but we aren't gonna expose it to the rest of the world. We are going to keep it as an Intuit trade secret. All right, going forward, now let me explain what WebSockets are. WebSockets is an application protocol that works over TCP. The idea behind the WebSocket protocol consists of reusing the established TCP connection between a client and server. So it differs from HTTP in a specific way. After the HTTP handshake, which it shares with the regular HTTP protocol, the client and server start speaking WebSocket protocol by exchanging WebSocket envelopes. So what this means for us is that it allows for two-way communication in the browser. And this basically allows us to communicate with the browser in a message bus type fashion. Now, before WebSockets, we used to have long polling and other stopgap measures, but they are not required anymore. Right? Polling is always not the best thing to do when you have a process that takes a long time and you want to communicate. WebSockets is the thing to go because it's supported by all major browsers now. And Spring also supports WebSockets, which is great for us because we use Spring a lot. Now, the other part of the puzzle is Redis PubSub. Okay, most of us use Redis for caching, but Redis also has a very good PubSub messaging framework built in. The terminology that Redis uses is a channel instead of a queue or a topic. Okay, it is kind of a message bus, but it's more of a PubSub architecture. A publisher publishes to a channel, and a subscriber subscribes to a channel or a pattern of channels. Okay, and keeping up with Redis, it's super fast. All of the PubSub commands take linear time, which is O of n plus m, where n is the number of clients subscribed directly to the channel and m is the number of subscribed patterns. What it basically means is that, let's say there is one channel and there are 5 subscribers assigned to a channel. It's gonna just take 5. It's gonna take, the time taken is the number of subscribers to that channel at that time, if you're directly subscribed to a channel instead of a pattern. Going forward to the architecture of our site. Okay. We have web app processes that serve requests coming in through a web app. All right. So first is we have the self-employed.into.com, which is open to our web servers, or to the website. And we have an API gateway that is managed across Intuit. What it does is that it provides an API gateway for the Android and iOS apps. Okay. We use Nginx as a web service, and web requests are handled by the app servers, while the API requests are handled by API servers. We have separate servers for these two. But they both talk to Redis. In addition, there's this thing in the middle, which is the worker processes. Okay, and these processes are the ones that do the heavy lifting. They allow us to scale without having to increase our app and API processes. What both the web app servers and the API servers do is to offload most of these long-running processes, or machine learning or anything else, over to the worker. And we use Redis PubSub mainly for that. Okay. So intra-process communication here is done using Redis PubSub, while communication between the internet and the app servers and Android and iOS and the API servers is done via WebSockets. I see there's another question here. Are you using Mahout for machine learning or something else? So we have a separate team, and we do use Hadoop and Hive, and they've been looking at the big data and coming up with, they've been doing a machine learning process. I'm not sure if they're using Mahout, but I'll be sure to ask them about it. How secure is your encryption algorithm? That's proprietary, so I'm sorry we won't be able to answer that. But I'm telling you that we mainly use HTTPS for communication on the from the internet for the WebSockets, basically. Okay. So yes. So we use Spring extensively on the backend. Some of the main framework projects that we use are the Spring Session, Spring MVC. We use Spring WebSockets for communication using WebSockets. We use spring-data-redis to communicate with Redis for both PubSub as well as for our caching needs. And then there's a bunch of other projects that we use. Anything that probably Spring makes, we try to use. And on the front end, we use AngularJS very extensively. For WebSockets, we use a WebSocket client called sock.js. Sock.js is a browser JavaScript library that provides a WebSocket-like object. Under the hood, sock.js tries to use native WebSockets first. Right. So if a browser doesn't have WebSockets or doesn't support WebSockets, or there is some issue, let's say there's a firewall, for example, it would fail, and it would use a variety of browser-specific transport protocols. In the end, it would boil down to using, long polling or short polling if the browser supports nothing else. And Storm.js is a text protocol over WebSocket, so it runs over sock.js. Is just a simple text protocol. And Storm.js, Storm is this text messaging protocol, and Storm.js implements that protocol for JavaScript. Now this protocol is very simple. You can write up a library probably in less than a day, but it can be used. It can be used not just over WebSockets, but it can be used over message bus as well. In fact, there's implementations of Storm.js for Apache and RabbitMQ, etc. Now let's look at the entire sequence that happens, in a rule recommendation or in a bank connection flow. So there's three actors here. There's the browser. There are the web app servers and the worker processes. So when a user launches a browser, signs in, and launches our app, the first things that we do is that we create a WebSocket connection. And then we subscribe to a queue. Now that's required so that what happens when you subscribe to a queue through a WebSocket is that we end up creating a Redis pub/sub channel for that user. So basically, every user that comes in and launches our app, we are creating a pub/sub channel for that particular user. When the user, let's say, tries to connect a bank or categorize a transaction, via WebSockets, we get the bank connection request to the worker. Actually, I'm sorry, this goes over HTTP only. But since the subscribe queue is there, it would listen for a bank connection publish, the backend, the web app servers. Okay. All the heavy work is done by the worker processes. This includes connecting to a bank, importing transactions, and finding their different categories. And there's a whole bunch of work that happens at the backend. And this is all done by the worker processes. So what we've been doing is that we've been increasing the number of worker processes that we have while keeping the web app servers and app servers very light. And that's our scaling mechanism for now. So after everything's done, the worker processes will then publish a connection successful event. And this will be published via the web app servers, which is listening to this event from the worker processes because of the Redis pub/sub. It in turn goes ahead and then publishes these to the WebSocket. The browser now gets this information and it informs the user of a successful connection. Okay. And this is pretty much the same thing what happens for the rule recommendation as well. Okay. Any long-running process that we have or anything that is asynchronous would be handled by WebSockets in our system. And Redis pub/sub, of course. Let me see if there are any questions. Yes, Kiran is asking the question, any specific reason to separate the app servers and API servers? Usually it's the same layer and set of communication, right? Yeah, so the question is there any specific reason to separate the app servers and API servers? Yes, and there is, mainly because we want our web, the UI goes out a little faster than our app servers, which require a rigid set of APIs, just because people are on different versions of our mobile apps. The way our mobile apps are published, it takes about a week for iOS to approve them, while Android might be fast, but there's a lot of fragmentation. So we want to make sure that we support them, and that's why there's different processes. While web can go super fast, we can iterate much quickly on the web because everything's under our control. And so we've kept those APIs separate. But why they are separate? They could be separate boxes as well, that's separate virtual machines. And the reason is that because we are planning to go global, we want to make sure that whatever is ready first, whether it's the web or the mobile apps, can be put into that region as soon as possible. I hope that answers your question. Okay, so now the big question, why do we reuse Redis for pub/sub? In our use cases, create and close channels dynamically hundreds of times a minute. This is a little different from a regular use case for a message bus. So, RabbitMQ, for example, can handle thousands of messages a second, but it's not built to handle hundreds of queues being created dynamically in a minute. And we want to create a different channel for every user. And the reason is that every user has its own particular pipe to the worker process, because we have this particular message would be for only a particular user, not for a bunch of users. and we want to enable two-way communication between these two. So we actually did go to production with RabbitMQ. We have multiple app servers, but the WebSocket is created only on one app server. That's because it's like one pipe that's on while the user has launched an app. And this server needs to listen to a message sent by the worker processes. So for one unique queue per user, RabbitMQ performance dropped dramatically after around 200 queues. We saw CPU spikes, and we couldn't explain that. There was no documentation or anything about RabbitMQ about this particular issue happening, where you have hundreds of queues that are being created. And so we dropped the idea of using RabbitMQ. So finally went with Redis for PubSub, and it's been performing very beautifully with no reliability or scalability issues for the last 6 months or so now. Going forward, now we're going to go through the entire workflow of a user launching an app and seeing your recommendation. And I'll be showing you mainly the backend code with both JavaScript for WebSockets as well as Spring, the WebSocket part and the Redis part. Okay. So when a user launches the app, the WebSocket connection is created, and the WebSocket sends a request to subscribe to the user's topic. Okay. So I'm gonna switch to the app now. Yeah, I'm gonna go forward. Let's refresh. This is on my machine. You can see we are connecting. These are WebSocket messages. And if you have Google, Google has, in the Google Developer Tools, you can see a WS, which is the WebSockets, where you can see all the WebSockets that are on right now. So this particular request is a WebSocket request that is connected right now for our app. Okay. And then we subscribe to a queue. In this case, it ends with user recommendation and has the user's email address. Okay, the front-end code. So this is a JavaScript, as you can see. In the front end, the connect function connects a WebSocket and subscribes to the queue, as we saw. The fire callbacks function right here is called for the UI subscribers, any of the UI that's subscribing to a particular event. For example, the rule recommendation event, if we can have multiple pages subscribing to this particular event, and then all of these pages, if any of them are live or shown to the user, will get that particular callback recommendation. Okay, that's this piece of code here, right here. But the main thing that's happening here is connection to a WebSocket and then subscribing to a queue. That's the one that's highlighted in yellow. I'm going to keep this up for just a few more seconds so that you can look over the code. And feel free to ask any questions whenever you have them. Okay, the first question is, can you please elaborate on your Redis setup? How many nodes, and are they replicated across data centers? So right now in Redis Sentinel, we are not replicating across data centers, but that is a work in progress. Redis Sentinel with 3 nodes, and since we're using Redis for PubSub, there's not much memory requirement. PubSub is super fast and its memory footprint is very small. So we've been not using a lot of space, memory or otherwise. There's another question from Mark Polak. You don't need a queue per user in RabbitMQ. You can use a topic or header exchange that contains the username. So we did try that as well, but we had a lot of issues getting that to work correctly. We spent about, I think, a month trying different things with RabbitMQ, but none of them actually worked. We did not use any other exchange type, right, like Apache. We directly went to Redis, and that worked very well for us. Okay, going forward, some backend code now. This class WebSocket config is the actual config for Spring. We have the @ configuration. If you guys know Spring, this @ configuration is the one that tells Spring that this is a configuration file. The enable WebSocket message broker annotation will basically make this, will tell Spring to enable WebSockets for our particular app. Okay, the configure message broker function will enable WebSockets on the /q, the /topic, and /user endpoints. And there's an application destination prefix, the /ws, and that's what you see in our WebSocket right here, the /ws. Okay, and then we have the endpoint where we initialize WebSockets with, and we tell Spring that we are also using sock.js protocol. So sock.js is also supported by Spring, and it helps us, it helps Spring process any request that's coming in via WebSocket. Okay, I'm going to keep this up again for a couple of minutes, couple of seconds. Prashant asks this question: are you using persistence with Redis, or is your pub/sub memory only? So our use cases right now are that the user should get a recommendation right after the thing has happened. The UI is waiting for a particular message. Like a rule recommendation would be useless if it's sent a few seconds later. So we don't have any persistence with Redis. We're using caching though. And another question from Prashant is, how do you deal with pub/sub going down? So if a pub/sub goes down, we do have redundancy in Redis. So that's a problem that is solved by just the fact that we are using Redis. For our bank connection flow, we do have fallback options though, just in case we have to bring down Redis for maintenance or something out of the blue happens. We do fall back to a long polling mechanism, which won't use Redis. But that hasn't happened as of yet in production. For rule recommendations, we really don't have anything else. But we haven't had the problem in production as yet. So now when the user launches the app and the WebSocket subscription occurs, when the WebSocket subscription occurs, Spring will send an event called a session subscribe event that we are listening to. This application listener, which has a generic type session subscribe event, will be the class that's listening to it. And what's going to happen is that we create a new queue for the user with the round tick key. This is in Redis. So we add a message listener for that particular channel topic for the user. Okay. So every user now has a unique pub/sub channel, and only that app process that listens to the WebSocket subscribes to the Redis channel. For example, if there are 5 app servers that's taking requests, but the WebSocket is connected to only one app server, only that app server will subscribe to the user's pub/sub channel. Okay, this is what you see in Redis. Okay, we do end up with thousands of channels in on a regular day, but Redis doesn't blink, you know. And with RabbitMQ, we've tried different ways of doing this, but RabbitMQ did not scale about 200 queues. And you know, during tax peak, we had over 4,000 simultaneous users on a site, all using. At that time, we had a single instance of Redis, but it worked like a charm. So we had no issues there at all. All right. So now, when the user starts categorizing transactions, like I showed you earlier, every transaction process is sent over to the worker for further processing. Okay. So we do make the change in our database, but then a request goes to the worker process for any machine learning or anything else that's required. So in the worker process, when it detects a possible rule, it publishes a message on the user's topic. Okay, so it says, we found a rule that we can recommend to the user, so we're going to publish it. And then it's sent over the same user PubSub channel. So now what happens on the app server is that we have a receiver class, user recommendation receiver, that's listening for this exact message. Once we get that message, we then relay this message over through the WebSocket. That's line 31 and 32, these lines. We are sending over this message over to the WebSocket to the browser. Okay, and in the end, this message that you see here has been sent via WebSocket, and the UI translates this over to a modal, and it says, as a user, if they want to create a new rule. And so the user sees a rule recommendation in the end. Okay, so an unexpected benefit of creating Redis channels is whenever a user launches our app, we can count the exact number of users who are on our site. Okay, and DevOps has written a script that runs every minute and captures the number of live channels in Redis. So this picture above you see, it was taken a while ago, and it shows that we have choose the number of users using our app over a 7-day period. So we know when we have less people using our app, when we have more, we can map it out. And so this is after tax season is over. During tax season, we definitely had record traffic. And so things like these help us understand how many users are using our web app and mobile apps at any given time, and how long they're staying on our site as well. So right now I've been showing you the UI for WebSockets for JavaScript, but what about mobile? So WebSockets are supported in iOS and Android as well. Okay. And for iOS, there's a library called StarterScreen. It's not, we don't have great support for them, but these libraries do work, so that's good for us. For Android, there's a library called Android WebSockets. Now, for the front end, we've been using Stomp, as we showed you, but Stomp support is not so great for mobile, as yet at least, but it's there. You know, iOS has a library called WebSocket Stomp Kit, while Android has one called Gozera. We had to make some changes to the WebSocket Stomp Kit to make it work with Spring, and we've contributed that back to this project, to the WebSocket Stomp Kits project. And you know what, you can still use WebSockets without Stomp anyways. A Stomp is just a simple text message protocol. You can always create your own, so it's not a big deal. Okay, so now I'm going to show you an iOS demo. Let me switch back to using an iOS simulator right now. Let me create a new account. Now this is our iOS app that is in an iOS simulator. So first we're going to add a bank. And it's using the same backend processes that our web app is using. Okay, and it's connected. So now let's go to the transactions to review again. So at this time, right, the WebSocket is again connected to the backend. I'm gonna again go down to these transactions, and right now I'm gonna categorize 3 transactions. And what our method is right now is to, let's say that a user categorizes 3 transactions as one type, and if we don't know that particular vendor is always business, that's what we are using. So now the create rule pops up using this exact same methodology as for the front-end JavaScript. Let's say the user says, yes, I'm going to apply it to all transactions. Those get categorized. Okay. I'm going to spend just a few seconds showing you our backend WebSocket code for iOS. I'm not really an iOS developer, but for those who are, you can see what we're doing here. If the command is a message, we're gonna this WebSocket StormKit is gonna take that message, process it just like StockJS and StormJS would do for the web, and then show a particular offer to the user. Okay. If there are any other questions, I can answer them right now. So I'll wait for a few seconds while you get your questions out there. Okay, there's one question, which is, what was the Redis channel limits that you reached? So we've tested up to 10,000 simultaneous channels at one time. Our peak traffic right now has reached 4,000 simultaneous transactions. That was at last tax season. This tax season, we are expecting at least a 5-fold increase in that, and we are preparing for that particular increase. One gotcha that we had when we started using WebSockets was that Nginx servers would only Nginx has a default of 1,000 files open at any given time. Now files here converts to connections, so it was only allowing 1,000 connections at any given time for WebSockets and for regular HTTP requests. We increased the default from 1,000 to 15,000, and we've not had any issues so far. So that's one gotcha. If you do need to use Nginx, keep that in mind. Okay. Shimon is asking this question: do you use Redis for web session management? And actually, we do. Spring Session is open source project from Spring, and what it does is that it uses Redis as a session management cache, so that a request from any particular user can be round robin, and the session, since it is in Redis, it can be available to every particular app server. Okay, so if you do have any questions, feel free to answer. But I'm going to put my contact info up here. You can email me if you need to, if you have any questions, or visit my GitHub site. And thank you very much for attending this talk.
Nainat, thank you, and thank you for taking time to provide an overview of Intuit's use case and for choosing Redis Labs. And to all of our participants, thank you for joining us on today's broadcast. You will be receiving an email with a link to the broadcast recording to replay and to also share with others. Again, thanks and have a great day.